Alright everyone, so this is the video over page 91. Now there is already a key, so I'm not going to do every single question, but I will talk about some of the important ones that we think you should take note of. So let's just quickly talk about number 3. It asks us to divide by 2x squared minus x plus 1. The only thing that I want you to take note of is it is missing a term. Missing a term. What term is it missing? It's missing the x cubed term. So when you're setting it up in the division sign, just make sure that you account for that. So it should be set up as 2x squared minus x plus 2. With this, we got 8x to the 4th. And then we're going to put that 0x cubed, because if you don't put it, it will mess you up. And that's all I have for number 3. That's the only important one. Number 2, you can definitely do, all right? And number 1, those are on the key. So now let's go down to the remainder theorem. So it says that if the polynomial is divided by a factor, x minus c, then whatever remainder I get is equal to that value p of c. So pretty much I'm going to write right here that using the remainder theorem, I know that p of c has to equal that remainder whenever I do that division, either through long division or synthetic division. So let's go to number 7 and let's actually do it. All right, so number 7 is asking us to find p of negative 2. Okay, well, just like I said before, using the remainder theorem, I know that p of negative 2 has to equal the remainder when I am dividing by x plus 2. That's for long division. We know that with synthetic division, we can keep it the same value, and I think you guys like synthetic division just a little bit better. So we're going to do that, and let's just remind ourselves of how to do the synthetic division. So we have our number in the corner, and my number is negative 2. Okay, I am going to write the coefficients of my terms. So I have 3, 5, negative 4. I am missing a term. I'm missing that x squared term, so I'm going to put 0, 7, and 3. Okay, the first number we always bring down, and we have this, all right? So my first number I bring down is 3. Then I'm going to take that 3, I'm going to multiply it by negative 2. I get negative 6. I'm going to add them together. Then I have that negative 1. We're going to do the same thing. Negative 1 times negative 2 is positive 2. That goes here. I add them together, I get negative 2. Then I'm going to do the same thing. Negative 2 times negative 2 is positive 4. Add them together. This becomes negative 8. Add them together. And the last one becomes positive 2. I add them together and I get 5. So what does that mean for the conclusion? The conclusion is that p of negative 2 has to equal 5 by the remainder theorem. What other things can I get from this? Well, because p of negative 2 equals 5, I know for sure that p of negative 2 cannot be a root. Because, remember, you can only be a root if your y value is 0, right? And so by using the remainder theorem, not only did I figure out that p of negative 2 was 5, but I figured out that it can't be a root or a 0 of the given polynomial. Okay, so now number 8 states the factor theorem. It basically says that by using the remainder theorem, if the remainder is 0, well then that factor, it has to be a 0 of the polynomial. All right, so we're going to test this out by doing number 9. All right, so because it says use the fact that p of 1 equals 0, I know that x minus 1 has to equal 0, therefore x minus 1 is a root. So we know that from the get-go. Let's do synthetic division now. So I'm going to put that 1 in the corner. I'm going to write my coefficients. So I have 1. I'm missing a x squared, so I'm going to put 0. Then I have negative 7 and 6. Okay, I'm going to draw this line. I know that I always bring this first one down. 1 times 1 is 1. I'm going to add them together. I get 1. 1 times 1 is still 1. Negative 7 plus 1 is negative 6. Negative 6 times 1 is negative 6. We add them together, we get 0. So right here, this does match the fact that we have, when I plug in 1 for synthetic division, I do get 0, so I do not have a remainder, which does mean that it's a factor. What else does it tell us? Well, from here, I have I have what's left over once I divided x minus 1 out, and what's left over is the quadratic x squared, 1x squared, plus 1x minus 6. So pretty much, if I divided this, if I long divided x minus 1 from x cubed plus 0x squared minus 7x plus 6, my remainder, my remaining polynomial would be x squared plus x minus 6 with a remainder of 0. So now, to find my remaining roots, I'm going to factor this out. And when I factor this out, I should get x plus 3 and x minus 2. That's from the remaining quadratic, right? I also know that from the very beginning, we learned that x minus 1 was a root. Therefore, this is my factored polynomial. This is the original p of x. And so, yeah, it just says factor the polynomial. There we go. So here's p of x. These are all my factors. Great. All right, and might as well just finish it up with number 10. So with number 10, I do want to find a polynomial that has degree 4, that has these zeros. Okay, if I have the zeros, I can work backwards and get the factor. Let's start off with this one. If I have a 0 at x equals 0, I know for sure that this factor is going to turn into just x. Okay, so this is just going to give me a factor of x. This one right here, if I have a 0 of negative 3, my factor is going to be x plus 3. Okay? This one right here, if I have a 0 of 1, my factor turns out to be x minus 1. And then this one over here, if I have a 0 of 5, my factor is going to be x minus 5. That's it. At this point, we have our polynomial. So I'm just going to label this f of x. What you can do is you can distribute this. And if you do distribute it, well, then you will eventually get degree 4 because we have 4 x's. And x times x times x times x is x to the 4th. And that's it. That was this quick little video going over some of the questions that we wanted to highlight a little bit more. And so there's that.